Alright kids, this is number 10 from the homework tonight that we're working on. And what you're really doing is you're just using a graphic organizer. Very similar to what we did in class where we took numbers and we sorted them underneath the word categories. However, this time it tells you to draw a diagram like the diagram of the sets of Z, Q, and R in this lesson. That was on page 23. I believe. And if you take a look at that page, you'll see an example of what all of those things are, even though we haven't actually talked about the letters that were represented here, right? This R, this Q, and Z. I mean, really, what does it mean? So R should be the obvious one. It stands for the real numbers. Q stands for the rational numbers. And we use the letter Q because Q stands, Q is a first letter of the word quotient. And if you remember from class today, when we talk about rational numbers, we're talking about decimals and simple fractions. So if you have anything that has a terminating decimal or a repeating decimal, then these are all rational numbers. And everything else is what we would call an irrational number. So let's begin with A. So A says square root of 6. Square root of 6, if you recall, has no perfect square. Because if we break square root of 6 down, we get root 2 and root 3. Both of these numbers are prime, and square root of prime numbers are automatically irrational. So we would put them under the real number category. However, we will not put it under the rational number category because it is not a rational number. It's made out of two irrational numbers, which gives you another irrational number. How about a 17 over 9? If I take 17 over 9, that just looks like a what? It looks like a fraction. So my fraction, 17 over 9, should go under the rational number inside this green area. And then square root of 144. Now if you can simplify a square root, always try to do so. And when you simplify square root of 144, you get the number 12. So where does 12 go? I know 12 is a real number, but I also know it's a rational number because I can write it as a fraction. It's 12 over 1, or 24 over 2, or 36 over 3. But it's also an integer because it is a positive counting number, which are part of the integers. So 12, or root 144, goes here because root 144 is 12. This next one, 11.55, it is a what kind of number? A decimal. 11.55, and decimals go under rational. The ones down here, square root of 13 plus square root of 3. I can see that square root of 13 is an irrational number, and square root of 3 is also an irrational number. So if I add two irrational numbers together, I should hypothetically get an irrational number. And there are some cases where this is not true, but we'll talk about those cases later. What about the square root of 2.5 squared? Well, recall that 2.5 squared, or anything squared and then taking the square root, just gives you that original number inside. So the square root of 2.5 squared just equals to 2.5, which is not an integer because it's not one of the counting numbers, positive or negative. It is instead a decimal, so my answer is just 2.5. 91 over 7, can I simplify 91 over 7? I'm actually not sure. Let's do 91 divided by 7. 7 goes into 91, 9 one time, and I get 21. 7 goes into 21 3 times, I get 21, that cancels out. My answer is 13, so 13 goes under the integers, 19 over 7, because it is a whole counting number. And last but not least, 1 plus radical 6. I have an irrational number and I am adding it to a rational number. Guess what? That still gives you an irrational number. So 1 plus root 6 just goes under real number. I hope this was helpful. If you have any more questions, we'll discuss some more of this tomorrow when we get some formal definitions and write some of this stuff down.